In this video, I will discuss the JEE Advanced PYQ from the topic Work, Energy and Power. This question is based on springs and energy stored in it. First, I'll give some basic ideas. Consider this spring or spring constant K, and let there be external force applied at one end. Now, what will happen to the spring? Will it get compressed? Actually, the spring will not get compressed, but it just move towards right. To compress the spring, I have to apply a force at the other end in opposite direction. Then the spring will get compressed by an amount x, and the energy stored in the spring will be half k x square. There is one more way I can compress the spring. Instead of applying a force at the other end, I can have a fixed support. In this case also, the spring will get compressed. The spring material which is shear will apply a force on this. Suppose it's a wall. Will apply a force on this wall, and wall will apply a equal and opposite reaction. So there will be a normal reaction from the wall or the fixed support to the spring, and this normal reaction will be equal to the applied force if the spring is massless. So here also the spring will get compressed by a certain amount, and the energy stored is half k x square. Instead of compressing the spring, I can also stretch it. So the same thing is true for stretching the spring. Suppose I have a spring like this. To stretch it, I have to pull on both the ends by equal force, or I can have a rigid support here. So when it's trying to pull, so this material will try to pull the wall, and wall will try to pull this material towards right. So normal reaction here will be like this, which will be equal to F. So here if the spring gets stretched by an amount x, the energy stored in the spring will be again half k x square. Here it is compression, here it is stretching. There is one more interesting point. Suppose instead of applying equal force at both the ends, suppose for example here I apply a force of say 5 Newton, and in this end I apply a force of say 3 Newton. In this case, will it get compressed? Actually, this 5 Newton I can consider as made up of 3 Newton plus 2 Newton. So 3 Newton force will compress the spring by an amount say x, and this 2 Newton force will try to move the spring towards right. So here there will be compression, and also spring will get translated towards right. Similarly for stretching, if there are unequal forces, means there will be compression or stretching depending on whether it's compression force or tensile force, and it will also translate. There is one more thing. Suppose I have a spring like this and apply a force, either stretching, compressing force or stretching force, but the other end there is no force applied, and it's also not fixed like this. Here I have a say some massless block which is free to move, and there is no friction. Suppose this thing is lying on a surface. So in this case also, there won't be any compression in the spring. Here there won't be any stretching. So here the energy stored in the spring will be 0, and the amount of stretching or compression will be 0. So with this understanding, we can solve this JEE Advanced question. This is the question. A block B is attached to two unstretched springs S1 and S2 with spring constants K and 4K respectively, figure 1. The other ends are attached to two identical supports M1 and M2, not attached to walls. The springs and supports have negligible mass. there is no friction anywhere. The block B is displaced towards wall 1 by a small distance x, figure 2, and released. The block returns and moves to a maximum distance y towards wall 2. Displacement x and y are measured with respect to the equilibrium position of the block B. The ratio y by x is. So this is the initial state. The springs are in a relaxed state and the block is here. So this block is getting displaced towards right by an amount x and released. So when this is pushed, this spring will get compressed. But since this spring, the other end is free to move, there won't be any compression or stretching of this spring. So here there is no, this spring is a relaxed state. But once it's released from here, the block will move towards here, and once it reaches here, it will have some velocity. So it will not stop here. It will go towards right, and when it reaches here, this M2 would have touched this wall. And when this block moved towards right, this spring S2 will get compressed. But this spring S1, since this end is free, it will not get stretched or compressed. It will be in a relaxed state. So after reaching this point, when it moves towards right, this spring S2 will get compressed and energy will be stored here. You can pause and attempt this question. So you have to find the ratio y by x. This can be done by energy conservation. Energy is stored in the system in the state 2. It's half. This spring is getting compressed, K1, by an amount x. This spring is relaxed positions. It will not get stretched or compressed because this end is free to move. So as soon as this block is moved, this will just go towards right without any stretching or compression. So only energy is stored here in this state 2. And when it is released, it will come back to the equilibrium position and move towards right. And when it reaches the extreme position on the right side, this block M2 would have touched this wall, and this block B would have moved here by an amount y from the equilibrium position, and the spring S2 here would have got compressed by an amount y. And this spring, since the support is free, will be in a relaxed state, and M1 will be somewhere here. So let me call this as state 3. So energy stored in this state 3 is energy stored in the spring, that's half. This spring, which is 2, K2, and the compression is y square. Energy stored in this spring is 0 because it's a relaxed state. Energy is conserved within these two states because there is no dissipation, there is no friction. So these two energies should be same. So equating these two, half will get cancelled. K1 is K, is given in the question, into x square, equal to K2 is 4 times K, 4K, the second spring, into y square. So y by x is 1 by 4 square root, it's half. Half is the correct answer. Since this spring 2 is tighter spring, the spring constant is 4K, the amount of compression of the spring will be less. This thing is relatively loose spring, so this thing will get compressed more. So that's why y is less, so y by x is a fraction less than 1. So this is what I explained here. Energy stored in the system in the state 2 is half k x square, and in the third state it is half k2, which is 4k, and the compression is y, so it's y square. So these two are equal. From this I'll get y by x as half.